Hey folks, today I wanted to give a quick demo of the revamped Fantasi Raytracer that I've built. I've worked on this project in the past as a software-based Raytracer, but I've now migrated it to be a GPU-based Raytracer. This time around it runs in real time. You can see that's what it's doing here, rather than taking seconds to render individual frames, like my old Fantasi project. I'll talk a bit more about some of the tech that I've used and the feature plans, but now I just want to guide you through some of the features. So I can easily move around the scene using the arrow keys, and holding shift gives me a little bit of up and down control. On the left you can see I've got some meta balls. If you've never seen them before, they're definitely worth looking up. You can find them on YouTube or find some cool papers on them. So pressing R, I can toggle different reflection depths. So I think here the reflection depth is 2 reflections, here's 3. Now you can see that I've got no reflections here. So I think 2 reflections looks pretty good, and it keeps a decent frame rate. Also by pressing 1, 2, or 3 I can change the anti-aliasing level to 1, 4, or 9 samples per pixel. Here's 4. Obviously, sampling at 4 samples per pixel breaks the frame rate a little bit, but it does produce some pretty stunning results. So now a little discussion about some of the tech I've used. In building this, I've used OpenGL's Compute shaders, a relatively new feature in the OpenGL toolset. I believe it came out in version 4.3. It's similar to Direct Compute and NVIDIA's CUDA technology. It allows just general computation to be deferred to the GPU. In my case, I'm using this to render each pixel in parallel into a texture, which I then use fragment and pixel shaders to display to the screen. One of the goals of this project is to maintain realism while keeping it running in real time. Few ray tracers I find run in real time. There are a few though, some pretty impressive ones. So right now I've implemented a semi-realistic lighting model that takes advantage of the Fresnel effect, which I only recently learned how to pronounce properly. I always thought it was the Fresnel effect, but no, it's pronounced Fresnel. So the materials I've got in my scene have refractive indices, absorption coefficients, and a bunch of other parameters that you can look through if you're curious in the code. So otherwise, I'm not actually using any acceleration structures, which might come as a surprise. There's no bounding volumes in my scene. The reason for this is because rendering on the GPU is quite different from rendering on the CPU. On the on the CPU, memory access is really trivial, but in a shader, memory access can get pretty expensive. Pointers are basically non-existent. So standard bounding volume and spatial partitioning structures like KD trees and stuff don't really translate well for the GPU. There are quite a few papers on the subject that I've seen, and some of them have some pretty cool ideas. Some of them way over my head, but one of the challenges for me will actually be to implement some of these into Fantasi. Otherwise, I'm intending to actually haul out some of the rendering calculations in favor of more physically based lighting. I'm getting some good realism here, but I'm sort of fudging the light equations a little bit to get some extra efficiency, as well as to make the scene look a little more vivid. I hope to have some pretty photorealistic stuff in the future. That's what I'm definitely aiming for. Oh, and in case you're wondering, I am on an NVIDIA GTX 670 video card. It's fairly beefy, so if the sample doesn't run well on your machine, yeah, you can just compile a Visual Studio project. But if it doesn't run well, you can try getting rid of the meta balls. The meta balls are the most expensive thing in the scene, as they use ray marching, which you can look up online. So with them out of the picture, I imagine frame rate should double or even triple. I think this video is getting a little long now, so I'm just gonna shut it down. Feel free to check the source code on GitHub. I'll post a link in the description. Also check out my website at thecodeboss.com for some more cool projects I'm working on. Thanks, and happy ray tracing!